Hi everyone, today we're going to be talking about how you can find the point of intersection of two lines in three-dimensional space. The first thing that's going to be important is that the lines are in parametric form. If you have two lines in Cartesian form, check back, I have another video about how you can convert it. But we're going to be looking at how to find that point of intersection, but before we begin, I think it's really important that you can visualize this. These are going to be the two lines we're going to be dealing with, and we're going to be looking to find the point of intersection in three-dimensional space. So you can spin it around and you can look at this geometric situation in different perspectives. If you're trying to prove that your lines do not intersect, then check this playlist because I have another video about that exactly for you. Okay, let's get started. So these are our three lines, and what I want you to do is I want you to set up an equation for x, an equation for y, and an equation for z. Okay, remembering that this is the parametric formula for x, y, z, x, y, z. That means that we're going to have three equations but only two unknowns. So that's a little bit superfluous, we don't need so many. I'm probably going to start out by working with just x and y. Once I found lambda, it'll be pretty easy, or I could find mu. If I found lambda or mu, I'm just going to plug it back in here and I'm going to have the coordinates that I need. So split your page up. This is your equations from R1 and this is your equations for R2. I'll write them all out, but you only need two. So my x equation is minus 3 plus 4 lambda on R1, and my x equation here would be 5 minus 3 mu. My y equation here would be 2 take away lambda, and my y equation here would be 2 lambda. My z equation for R1 is going to be 1 plus 3 lambda, and my z equation for R2 is going to be 7 minus mu. You can pick any two pairs out of the three. I'm personally going to pick x and y. So first of all, let's look at the equations for x and make them equal to each other. Remember, if they're going to intersect in three-dimensional space, the x-coordinate on line 1 needs to be equal to the x-coordinate on line 2, right? They have to be the same. So it would make sense that this x equation here would equal to this one over here. I'm going to rearrange it slightly so it looks like a bit more of a friendly version to work with. So I'm going to have 4 lambda plus 3 mu equals 5 plus 3, which would be 8. Okay, that's my first equation. I'm going to repeat this process for y with 2 minus lambda equals to 2 mu. I'm going to bring the 2 mu over, so I've got minus lambda minus 2 mu equals minus 2. Okay, and I'm going to solve those simultaneously to find lambda and mu. To solve this simultaneous equation, I'm going to multiply this by 4, so that I would have a plus 4 lambda and a minus 4 lambda. So this would be 4 lambda plus 3 mu is equal to 8. And this would be minus 4 lambda minus 8 mu equals to minus 8. I'm going to add these two together now. And then that's going to have plus 4 minus 4, which is exactly what I want. So this is going to be minus 5 mu. And this is going to equal to 0. So that must mean mu must equal to 0. I could stop right there if I know that mu is 0 and loop back here and plug in 0. And my point of intersection, if this is 0, this would be 5 plus 0 times minus 3, 0 times 2, this. So this actually would be my point of intersection. But I'm going to keep going and just double check so that I can be a little bit more secure in my calculation. If mu is 0, it should make sense that 4 lambda, if I go back here, okay, if I plug in mu is 0 to here, plus 3 times 0 is equal to 8. So 4 lambda should equal to 8, or lambda should equal to 2. Like I said, this is a bit superfluous, but it does give me a way that I can check my calculations. So what I can do here, if I have solved for both lambda and mu, is go back to my parametric equations that I set up and just really check them. So if lambda is 2, this would be, I could substitute 2 in all of these places. Here I would get minus 3 plus 8, which would be 5. Here I would get 2 minus 2, which would be 0. And here I would get 1 plus 3 times 2, which would be 7. Now I'm going to check that against what I get here. Now if mu is 0, it would be 5 minus 3 times 0. So it would be 5. 2 times 0 is 0. 7 minus 0 is 7. So I can definitely see that my point of intersection is 507. And that's exactly what we visualized in 3 dimensions as our point of intersection, 507. I hope this really helps you today. I love making these videos. If you would like and subscribe, that would mean the world to me. Thank you so much, guys.